Hey everyone, it's Mrs. Lawrence, and I'm here to go over a concept called combining like terms or simplifying expressions. It's something that you were introduced to in middle school. It's probably been a minute since you've done it, so we're going to go through it. This is really going to set us up for success with algebra. This this concept is prevalent throughout algebra, so we want to make sure you are super prepared for that. So without further ado, let's go. Let's get this combining like terms stuff down. So to start us off, we're going to watch a quick video. We're not going to watch the whole thing, just a little snippet to introduce the idea. Sometimes this might help you conceptualize what I'm talking about when we're talking about combining like terms. So kind of a different way to think about it. So when we're combining, we're really looking at that adding, we're bringing together the coefficients. So again, like terms, they have to have the same variable, and the important part is going to be the power. That kind of can trip us up. The same variable, same power. So who's on the same team with this Mario Kart game? FYI, I am awesome at Mario Kart. I wish there was a way I could take y'all on. If there is, let me know. I'm down to play. Video of a basketball game. Who's on the same team? I assume we all can figure this all out on who's on the same team. And then looking at these group of terms, all these monomials, how do we know who's on the same team? So they've highlighted some in red. What makes them all teammates? See if you can figure that out. What makes them all the same teammate?
In this tutorial, we're talking about combining like terms. And in the intro, we learned that like terms are terms that have the same variable and the same power, or the same exponent. And we saw a couple real-life examples. We saw a Mario Kart game and a basketball game. And in the videos, I asked who is on the same team. Well, let's take a look at a picture here. We have a picture of a basketball game. Who would you say is on the same team here? I'm going to go ahead and highlight some guys that I see that are on the same team. The guys in the white jerseys are on the same team. How did I know that? Because they're wearing the same colored jerseys. That's how we tell that they're teammates. Well, with combining like terms, is basically the same thing. We're looking for people or terms that have the same jersey or they look the same. So let's take a look at an Algebra 1 example. We have the example.
No, thank you. We're going to do that ourselves. So, in the video is just talking about like the same team. So in the Mario Kart game, in the battle there, you knew they were on the same team as if one was red, one was blue. Basketball game, one team was wearing white jerseys, the other team was wearing blue jerseys. So that signifies that they are on a team together. So I want you to think about that as we go through and we talk about combining like terms. So a polynomial, which you talked about in our last piece, is just an algebraic expression, and it's broken down into different parts. And we talked about those parts, but if you need a refresher, here it is in this picture. So we have terms, which are down below in the pinkish purplish color, that 2x, 4y, and 9. Those are all of our terms. Remember, terms are separated by plus or minus signs. Then we have variables, which are in red in this picture. So x and y are variables. That means they stand for two different things. X has a certain value, y has its own separate value. They're not the same value because they're not the same letter. And then we have our coefficients. Remember, that's a fancy way of saying the number in front of the variable. So our coefficient here is in blue. And then we have constants. And constants, remember, are just the number. New variables. Never will have a variable because a constant doesn't change. So our constant in this expression was 9. So just a refresher memory from last time. So when we talk about simplifying an algebraic expression, we're just it literally means to make it simpler. So sometimes in algebra, those expressions can be really, really long. And it can get really, really confusing. So we want to condense it down into a nice, neat little package where everything that is similar or the same is joined together on, if you want to call it, its own team. So we just want to make it organized. We want to make it neater. We don't want to be like this lady sitting at her desk with all those papers all over the place. We want to kind of put it all in its own little file drawer, if you will. So like terms have exactly the same variable factors. So in the video it talked about that. To be a like term, you have to have the same variable, or the same letter, if you will, and then it's got to be raised to the same power, either squared or cubed or to the fourth power, or maybe just to the first power, whatever it is, but it's got to have the same. Constants are always like terms. Like 9 and 12. Those are like terms because I can just combine 9 and 12 and make 21. So they're like terms on their own. So let's look at this example. We have 3a minus 7 plus 5b minus 6a plus 10 minus 2b. That is what I'm talking about. That's a lot of information. I want to see, can I make it smaller, make it fit in a nice little neat package? And yes, we can. So I'm looking for those like terms. I want to put the teammates together on the same team. It's like y'all walked in the gym at the same time and you're trying to get your team together over on the side. So we start with 3a, and 3a is like, where's my teammate? Where is my teammate? And 3a spots minus 6a. Notice I circled the minus sign in front of the 6a because that's going to be important here in a second. So he's like, oh, there you are. They come together. They're going to come together and they're going to join on their team. So then we have 5b, and 5b is like, wow, where's my guy? Where's my teammate? And, oh, there it is, negative 2b. They both have the letter B at the end. They're on the same team. Again, notice how I included, when I boxed this, the minus sign. Then we have our constants. So negative sounds like, man, do I have a teammate? And they're like, oh, yeah, I do. There's 10. We can be on the same team because we're the same. So we can now combine them by simply adding the coefficients. The word combine is to bring together. So when you combine something, you're adding it together, essentially. So we're going to start with our circled terms. We had 3a minus 6a, and this is why I said it's key to include the minus side. Because when I'm bringing these together, it's not just going to become 9a, because what we have here is this negative 6a. So if you remember about not adding and subtracting with integers, it's important that when the signs are not the same, remember, you take their difference and give it the sign of the larger absolute value. Or if you just put in your calculator, and if you need a calculator, if you look at the Schoology homepage, I have a calculator embedded there, or use your phone. But 3 minus 6, if you put in your calculator 3 minus 6, you're going to get negative 3. So it's negative 3a. Team White Rectangles gets together, and they're going to join, and we have 5b minus 2b, or just 5 minus 2, because we're not worrying about the variable. 5 minus 2 is 3. I put a plus sign in front of it because it's a positive 3. And then finally our constants, negative 7 plus 10. And again, I got to make sure I pay attention to those integer rules. It's not 3. It's not going to be 17, but it's going to be positive 3. I did say it's not going to be 3. I meant negative 3. But it's going to be positive 3. See, I make mistakes too sometimes. So we have negative 3a plus 3b plus 3, because negative 7 plus 10 is a positive 3. So this is it. That's the final answer. Don't try to make it smaller. Don't try like, well, it's not one thing. In algebra, it's not always going to be just one thing as an answer. It's not going to just be 17 or, 18R. Sometimes this is our final answer, and that's okay. That's as small as it's going to get. You got to be okay with it. So let's do some practice. We're going to do a couple together, and then you're going to do a couple on your own. I'll review the answers after you finish the Ed puzzle. You'll see your answer once you've answered the question. So the first example, 4a plus 7 plus 2a. So again, you're looking for those like terms. Think about it. Do I have teammates? These are 3 players in the gym. Where is their teammate? Do they have a teammate? So I see 4a, I see 2a. They both have an a at the end. They're teammates. They come together. They make 6a. And then 7, it's 2-on-1 here. He doesn't have a teammate, so he's going to be by himself. Let's look at number 2. Negative 4x plus 3 minus 3x plus 8 plus 2. So I'm going to start looking for those teammates again. Negative 4x is that first term in there. Do we have any more x's? We sure do. We have negative 4x, negative 3x. Again, pay attention to the sign in front of the number. If you put this in your calculator, you are putting in negative 4 minus 3. Negative 4 minus 3, you get negative 7. So it's going to be negative 7x. Kind of skipped ahead already to the final answer. And then it's 3 plus 8 plus 2. So 3 and 8 is 11, plus another 2, we get 13. Do not try to make that smaller. That x is blocking your way. You can't. So now you are going to try some on your own here. So the first one you're going to do is number 3. So go ahead and put that answer into the Ed puzzle. Hopefully you got 9h minus 1. So again, you're looking for those teammates. I see 12h. I see negative h. Remember, that's like negative 1h. Remember, those ones are invisible. They're shy. They hide. And then we have minus 2h. So 12 minus 1 is 11. And then 11 minus 2 is 9. That's how we get the 9. And then we have negative 17 plus 16. So again, if I put in my calculator, it's got to be negative 17 plus 16. And I get negative 1. Try number 4. Did you get this? I hope you did. So teammates, negative 4x, negative 3x. So negative 4, negative 3, that's negative 7x. Then I look for my constant, this guy here, 3 minus 8. 3 minus 8 is going to be negative 5 or minus 5 here. Oh, did I trick anybody? I hope not. This 2x squared, why wasn't this combined? Why can these not be combined? Yeah, they can't be combined because this has a to the second power. This one doesn't. Remember, they have to be to the same power. So it's almost like it's like a different letter, if you want to think of it that way. They're not on the same team. They're close, not on the same team though. Maybe they're both in the same like conference, but they're not. They can't be on the same team. And then finally, 5. There's a lot of terms there. Again, look at those variables. Look at what power they're raised to before you start collecting like terms. So this one, it only reduced down. It still has 4 terms. That's still a lot, but that's as small as we can get it. So we got 10h by taking 12h minus 2h. So if I have 12 h's, I take 2 h's away. I'm left with 10 h's. And then we have 12g by taking negative 4 plus 16. So negative 4 plus 16 is a positive 12g. I have h squared because of this third term here, right here. There's no more h's squared. I can't square any more h's, so it just stays there. And we got positive 3gh squared, again, from at the end here. There's no other terms that have a gh squared. There's some that have a g, there's some that have an h squared, but there's not any other terms that have them together. So good job. I hope you did well on that. If you feel like you are struggling and you're not sure, please check in with me with office hours, email me, contact me, and we can go over some more practice together. So you are done with this. You've finished your second piece of the building knowledge slice for this week. So you're going to move on to the third piece. So great job. Again, if you need any help with anything, please make sure you are reaching out or you're coming to the class meetings every twice a week or set up office hours, but just stay in contact. All right. See you later.